Hi guys, sorry I can't be there in person today, but that's okay. I'm coming to you digitally over screen to help you guys get started on your Noble Gas NV activity that you'll be doing today. Alright, so you guys each should have some cards or pieces of paper in front of you that are numbered 1 through 20 and then 31 through 38. Each group of 6 should have those cards and already be passed out among you. If not, please pause this little video and get that going. Okay, so to get you started, what I'm going to do is kind of go over a couple of examples of what you're going to do on your cards. Okay, so I'm going to actually go over the 2 examples that are on the class handout for you, sodium and fluorine, and I'm going to show you stepwise how this is going to go. So if you want to take one of your cards out and kind of do the same thing that I'm doing, except obviously for your numbered card, that would be a great kind of tool to help you get started. So my card here is number 11, and so if I look on the periodic table, I'm going to see that number 11 is sodium. So I'm going to put the word sodium, or the name sodium, up on top. Okay, I'm going to put his symbol right next to it. So sodium, Na. All right, the first thing that you're going to do is you're going to draw a picture of sodium. And so in the middle, we're going to draw our nucleus. And we're going to see, for example, that sodium is number 11. So that means he's got 11 protons. So I'm going to put 11P in the middle. All right, and sodium's mass is 22.99, which is very close to 23. So we're always gonna draw the most abundant isotope. So we're gonna round that mass number to the nearest whole number. And so for sodium, it's gonna be 23. And so if the mass is 23 and I have 11 protons, that means that I'm gonna have 12 neutrons. So in the middle there, I'm gonna write the number 12 and put an N for neutrons. All right, so that is our nucleus. All right, and then next I have to put those electrons. So this is like a review from last unit. We're going to put as many shells as there are. So sodium is in the 3rd row, so he's going to have 3 shells. So I'm going to draw 3 shells on my paper. Okay. So those are my 3 shells. And next, what I'm going to do is I'm going to put the electrons in. So he's got 11 electrons total. And if I look and see, sodium is in group 1A. So that means he has 1 valence electron. So always start with your valence electrons. So I'm going to put 1 valence electron here. Okay. And now I've got to place all the rest of them. So I'm going to go back to the center one because the atoms are always going to start filling in their electrons from the first shell out. So I'm going to put 2 in that first shell because remember that's how many the first shell holds. And the second shell, if you recall, holds 8. So I'm going to put 8 electrons in that shell. Okay, and so there are my 11 electrons for sodium. All right, so now that we have our drawing of our atom that we have in our card, what we're going to do is we're going to figure out whether when these atoms are going to make ionic bonds. Ionic bonds always occur between metal and nonmetal atoms, and what happens is that they get a transfer of electrons. So if you're a metal atom, you're going to lose your electrons. And if you're a non-metal atom, you're going to get electrons. You're going to try to steal other atoms' electrons until you get to the happy number 8. Okay? So remember, happy number is 8. Okay? So sodium is a metal atom, and so he is going to lose his electron. So on your cards, if you have a metal atom in front of you, you're going to lose your valence electrons, whether you have 1 valence electrons or whether you have like 3 or 4 valence electrons, you're going to lose them. Okay, so we're going to depict that on our on our card. So he has 1 valence electron, so we're going to circle that valence electron and we're going to put an arrow out. We're going to say lose 1 electron. Now, if the one that you're working with has more than 1 valence electron, so say you have magnesium and he has 2 valence electrons, it's all or nothing, all right? So he's going to lose both his valence electrons. Or if you're working with aluminum, who has 3 valence electrons, you guys are going to circle all 3 valence electrons and say lose 3 electrons. It's always you lose them all, okay, or nothing happens. So please keep that in mind. All right, so the last thing that we're going to do on our card is that however many electrons they lose, however many valence electrons, remember it's only the valence ones, however many they lose, that's going to become their charge, okay, because now they have an imbalance of protons and electrons. So for example, when sodium is losing his 1 valence electron, now he has only 10 electrons left, and he's got 11 protons. So now he's got 1 more proton than electrons. And so we need to depict that and say that he becomes sodium, the positive 1 charge. Okay? So if, for example, if your card has 2 valence electrons and it loses both, 2 valence electrons, then your atom will become a positive 2 ion. So for example, magnesium, we put Mg with a +2. Or like the aluminum, like I was talking about last time, if you have aluminum and it loses all 3 of its valence electrons, aluminum would be Al with a positive 3 charge. Okay, because now he's got 3 more protons than he has electrons. All right, so once you've completed that for one of your cards, you're going to do the same for all the rest of your cards. You should have either 3 or 4 cards in front of you. All right, so that's an example of a metal atom. Let's take a look at fluorine, who is a non-metal atom. Okay, so here's another example with number 9. Atomic number 9 is fluorine, so I'm going to put his name up there, fluorine, and his symbol is F. And just like before, we're going to draw his atom out. So I'm going to draw a nucleus. Fluorine is number 9, so that means he has 9 protons in his nucleus. And if you take a look at his mass, it is 19.0. Okay, so 19 is the mass, minus 9 protons would be 10 neutrons. So I'm going to put 10 N in the middle for neutrons. Now, fluorine is in the second row of our periodic table, so that means he has 2 shells. So I'm going to draw 2 shells there. And in those 2 shells, I'm going to put his electrons. Now, if he's got 9 protons, that means he's going to have 9 electrons. And so if I take a look, fluorine is in group 7A. So he has 7 valence electrons. So I'm going to draw his 7, 2, 3, 4, 5, 6, 7. Okay? And then his 2 more are going to go in that first shell. So now we have a total of 9 electrons. Now if we take a look at fluorine, fluorine has 7 valence electrons. All right? And if you remember the electronegativity trend, okay, that says as you go across the periodic table, electronegativity is going to increase, right? Electronegativity is the ability to attract electrons. So fluorine has super high electronegativity. That means he's going to want to get an electron, okay, or as many electrons as he needs in order to get 8 in his valence shell. Right now, fluorine has 7 valence electrons, so that means to get to the happy number of 8, okay, happy number equals 8. Okay, he's going to want to gain 1 electron. So we're going to depict that in our picture. We're going to draw 1 more electron. We're going to put a little arrow that says gains 1 electron. Now, if we count them up, fluorine has 10 electrons total. He's got 10 electrons and 9 protons. That means he has more electrons than protons, and so he's going to have a negative charge. All right, and so we need to depict that and say F for fluorine, and he's going to have a -1 charge. So he's going to be a -1 ion, we call it. All right, and so that's how you're going to do the cards for nonmetals. Nonmetals will always gain enough electrons in order to get that happy number 8. So if you're working with anything in group number 6, like oxygen or sulfur, they have 6 valence electrons. So how many more do they need to get 8? They need to gain 2. So on your card, you will say gains 2, okay, and draw in 2 more electrons in the outer shell. Same thing if you have are working with an atom in the 5th column, okay, or group 5A, they have 5 valence electrons, like nitrogen. So if you have one that has 5 valence electrons, how many more do they need to gain to get 8? Well, they would need to gain 3. So you would draw 3 more valence electrons and put in, gains 3 electrons. And now they're going to have a charge of -3, okay, because they're going to have 3 more electrons than protons. All right, so hopefully this helps. And what I want to do is just one more thing, taking a look at group 4A, okay, and also the noble gases. Okay, so if you have to draw something that's in group 4A, now this is not drawn correctly, this is just an example. I want to talk to you about those electrons. He has 4 electrons, okay, so he's kind of right there in the middle. He could either lose those 4 electrons or he could gain 4 more. It's an even tie. Okay, and so what you're going to do is you're going to basically write that on your papers. Either gain 4 electrons or lose 4 electrons. Okay, and so they're going to go either way. Okay, so all of group 4 is going to say gain 4 electrons or lose 4 electrons. But make sure that you are drawing them correctly with the correct number of protons and electrons in the actual atom, not like this. Now, if they gain 4 electrons, okay, then they're going to have a -4 charge. If they lose 4 electrons, they're going to have a +4 charge. So please put, whatever the symbol is, and -4 / symbol +4. Now, noble gases, on the other hand, already have 8. So if they already have 8 in their valence shell, they are already happy. They don't want any more. All right? And so if you have a noble gas, you're going to put gain / lose 0. Okay? And they are not going to make ions. They will always have an equal number of protons and neutrons. So you would put, the symbol with a 0 up on top. Okay? All right. So, take the next probably 15-20 minutes and finish up all of your cards correctly with the number of protons, neutrons in the nucleus, and then the correct number of shells with the electrons on the outside. And once you're done, keep going with the directions on the sheet. You're going to, in your groups, arrange these like the periodic table, and you're going to answer the questions in part 2, and then use that information to go on to part 3. All right, and I will see you next class.